Hello and welcome to this A-level maths video, which is the second of two videos I have on proof by contradiction. You can see these videos in either order, it really doesn't matter. And the purpose of this video is to prove that the square root of 2 is not a rational number. Now, this may not be the proof you will find in a book or online. This may be slightly different from that, and this is a proof which I prefer because I find when I explain the standard proof, if you like, and I say to people, did you understand that? They sometimes say, well, sort of. And I would much rather that they said, yes, I understood it. So there's a piece of assumed knowledge here, the fundamental theorem of arithmetic, which states that every positive integer greater than 1 is either a prime or has a unique prime factorization. For instance, 17 is a prime. 18 is 2 by 3 by 3, and that prime factorization is unique. And that is called the fundamental theorem of arithmetic. Okay, so let's have a look then. Let's see how we prove that the square root of 2 is not a rational number. That means that you can't write it as a fraction, and if you write it as a decimal, it doesn't terminate or recur. So as a decimal, the square root of 2 is 1.414 ... Goes on forever, never stops, never recurs. Okay, so how do I prove it? Well, I'm going to prove it by contradiction, which means I assume the opposite of what I'm trying to prove. So I assume that the square root of 2 is a over b, where a and b are positive integers. What do I do now? Well, there's no hope whatsoever of solving that equation, one equation, two unknowns, but I can sort of proceed as though I was going to solve it, and I think the first obvious thing to do is square both sides, and I get that, a squared over b squared equals 2, so a squared equals 2b squared. Right, now I'm going to proceed with that equation, a squared equals 2b squared. I can't solve it, I can't find out what a and b are, but what I can do is I can ask, what are the prime factors of the left-hand side and the right-hand side? Now, first of all, I need to know, what are the prime factors of a? Well, I have absolutely no idea at all, but it must have a certain number of prime factors. And what are the prime factors of a squared? Well, again, I don't know what they are, but it must be, and it must have an even number of prime factors. How many prime factors is a squared? An even number. Why is that? Well, suppose a is 18, then its prime factors are 2 by 3 by 3. And so the prime factors of a squared are 2 by 3 by 3 times 2 by 3 by 3. That's an even number of prime factors. And that simply happens because twice any positive number is even. Okay, so this is where we are now. A squared is 2b squared. A squared has an even number of prime factors. Now, of course, by the same logic, b squared has an even number of prime factors. So what about 2b squared? Oh dear. 2b squared must have an odd number of prime factors, simply because 2 is a prime number and its prime factors are just 2. So what I've found so far is this. When I look at that equation and write down the number of prime factors on the left-hand side and the right-hand side, a squared has an even number of prime factors and 2b squared has an odd number of prime factors. B squared has an even number of prime factors and 2b squared has an odd number of prime factors. So I have to conclude that somewhere, I don't know what this number is, but somewhere there is a positive integer which is both even and odd at the same time. So if I believe that root 2 is a rational number, then we're forced to believe that somewhere there's an integer which is both even and odd, or that our algebra so far is wrong. Well, I promise you it's not wrong. So, since our algebra contains no mistakes, there is an integer which is both even and odd at the same time, or square root of 2 is not a rational number, and that's the one I'm going for. I'm not very happy to believe that there is a positive integer which is even and odd at the same time, so I'm going to go for the fact that square root of 2 is not a rational number. Well, that more or less concludes this video, and that's a very beautiful proof. I hope you will agree, and I hope you will also see how you can extend it to cover the square root of any prime number. For instance, if I want to prove that the square root of 3 is irrational, then I just write down all the algebra I've written so far, and I replace the 2 with a 3. And you can see in this final step here, I'll have a squared equals 3b squared. What are the prime factors of 3b squared? Well, b squared has an even number of prime factors. Prime factors of 3 are 3, and so the right-hand side has an odd number of prime factors. So we can see that the square root of any prime number must be irrational. Thank you for watching this video.